Good day, everyone. I'm Jima Ade Samuel, and today we'll be treating measure of central tendency. So when we talk of measure of central tendency, it is a single value that summarizes a set of data. It actually locates the center of the values. For the sake of this study, the measures of central tendency to consider are one, arithmetic weighted mean, mode, median, and geometric mean. So we'll be taking this one after the other, explain and solve examples under these measure of central tendency. So to begin with, arithmetic tendency or arithmetic mean. So the arithmetic mean is the usual one we all know. So under this measure of central tendency, there are two main calculations, which is the arithmetic mean for the population and the arithmetic mean for the sample. So we will proceed with population mean. Population mean. And it comes along with a formula. So the formula for population mean is sum of all the values in the population divided by the number of values in the population. I'll urge you to state this formula down as we solve an example under this. And this formula can be represented in mathematical terms. So it's being represented mathematically like this. So we solve an example here. So it says marks obtained by 10 students in business mathematics are given below. So these are the marks obtained by 10 students in business mathematics. And we are asked to calculate the arithmetic mean. So now the arithmetic mean of these marks are going to be the addition of all these marks divided by the number of students. The addition of all these marks divided by the number of students. So we are going to do our calculation here. The number of students are 10. So we have 10 students here. So we will do our calculation here. So we have 46 plus 50, 46 plus 52 plus 75 plus 40 plus 70 plus 43 plus 40 plus 65 plus 35 and plus 48. When you are to add, you are getting 514. Getting 514, and you divide this 514 by the number of students, which is 10. So when you divide it by 10, you are getting 51.4. You are getting 51.4, and 51.4 is therefore our arithmetic mean. So we proceed to sample mean. We proceed to sample mean. And bear in mind the population mean and the population mean and sample mean are all under the arithmetic mean. So with a sample mean, we select a sample from the population in order to find out something about a specific character of the population. So with a sample mean, we turn out a particular a particular figure from the population. So its formula is also the same as that of the population mean, which is the so the x is the x bar. So this is what we are actually talking about. So these are some terms you would have to know because there are other questions packed and full questions that we will be solving. But if you don't get it from now, you are not going to get how you'll be solving those questions. So we move on to weighted mean. Now we are done with arithmetic mean. We move on to weighted mean. So under the arithmetic mean, we had the population and the sample mean. So we move on to weighted mean. So the weighted mean is a special loss of the arithmetic mean. It occurs when there are several observations of the same value which might occur if the data have been grouped into frequency distribution. So in general, the weighted mean of a set of numbers designated x. So this is actually explaining the formula to you. So we are going to state the formula of the weighted mean, then we solve an example on it. So I'll plead that you write down the formula for the weighted mean. So let's solve an example of the weighted mean. So the first example under the weighted mean is the quality construction company. The quality construction company paid its hourly employees 6,500 Ghana cedis. 6,500 Ghana cedis. 7,500 Ghana cedis. 8,500 Ghana cedis per hour. There are 26 hourly employees. 14 are paid at 6,500 rate. So 14 are paid at 6,500 rate. 10 at 7,500. 10 at 7,500 and 2 at 8,500. So now let's solve our question since we have our figures here. So we state the formula. The formula stated clearly that so now let's input our figures. So the W here is going to be our number of employees. The W is going to be our number of employees. So we have 14. Then the X is going to be our rate. So 14 times what? Or 14 multiplying 6,500. 14 multiplying 6,500 plus 10 multiplying 7,500 plus 2 multiplying 8,500 all over. Now you add the number of employees you stated here. The number of employees you stated here. So 14 plus 10 plus 2. So now let's solve here. So 14 multiplying 6,500 is giving you 91,000. It's giving you 91,000 plus 10 multiplying 7,500 is giving you 75,000 Ghana cedis. And plus 2 multiplying 85,000. You are getting 17,000. You are getting 17,000. You are getting 17,000. So when you add the 10 to the 14, you are getting 24, then the 2, you are getting 26. So now let's add all what we had as the numerator. So you are getting 183,000. So the 183,000 divided by 26. You are getting 738.46. 738.46, and that will be our weighted mean. That will be our weighted mean. So this is how to compute weighted mean. So we move on to median. But before we move on to median, we would have to move on to geometric mean first. We would have to move on to geometric mean first. So with geometric mean, this is the formula for geometric mean. So this is the formula for geometric mean. So let's solve an example under the geometric mean. So first example under geometric mean is the profits earned by Consa Construction Company on 4 recent projects were 3%. 3%, 2%, 4%, and 6%. I repeat the question. It says the profits earned by Consa Construction Company on 4 recent projects were 3%, 2%, 4%, and 6%. What is the geometric mean project? So this is the formula here. The n is going to be the number of projects. So we have 1, 2, 3, 4. So the n here is going to be 4. And after inputting the n, you continue to input the percentages here and you multiply them. So let's go. So our n is to be 4. Then our 3%, our 2%, our 4%, and our 6%. So this is what we are getting. Getting 4. So, you are getting 48. You are getting 48. So, this is how geometric mean is being solved. This is how geometric mean is being solved. Don't forget that the n is the number of projects per this question. So, you first input your n, which is 4, because the projects are 4. The projects are 4, and after stating your 4, you continue to state your percentages, which is 3, 2, 4, and 6. Then you multiply. After multiplying them, you state it in your calculator as you see here. Then you are getting 48. You are getting 48. So now we move on to the same geometric mean, but another application of the geometric mean. Another application of the geometric mean. So a second application of geometric mean is to find an average percent increase over a period of time. For example, if you earned 30,000 a year in 1990 and 50,000 in the year 2000, what is your annual rate of increase over the period? The second application, we are solving an example under the second application. It says if you earned 30,000 a year in 1990, so 30,000 Ghana cedis 1990 and 50,000 in 2000. In 2000, what is your annual rate of increase over the period? What is your annual rate of increase over the period? So when you are giving such question, you are going to apply geometric mean. And in application of this geometric mean, the formula changes And this is the formula you are going to use when such questions are being given to you. So the formula then changes to n, then become value at the end of period divided by value at the beginning of period minus 1. Minus 1. The 1 shouldn't be in this, so please. The 1 should be out, so minus 1. Minus 1. So this is the application we are talking about. So I repeat the question, then we use this formula to solve the question. It says, if you earn 30,000 a year in 1990, so 1990 is the what? Is the beginning year. And 50,000 in the year 2000. So 1990 comes before 2000. So therefore 2000 is the ending year. What is your annual rate of increase over the period? What is your annual rate of increase over the period? So now let's apply here. Let's apply here. So the value at the end of period is 50,000 because the end of period is 2000. So 50,000 divided by value at the beginning of period. The value at the beginning of period is 30,000. Is 30,000. So we have our value at the end of period, and we also have our value at the beginning of period. Now we are left with our n. Let's bring our minus 1 here. So we are left with our n. The n wasn't given in this question, so someone will ask, how then do you get your n, and you fix it here? The n should be the number of years. So now the number of years, you've been given 1990 and 2000. So you subtract 1990 from 2000, and when you do that, it's a period of 10 years. It's a period of 10 years, so you state it here. So now let's take our calculator, then input our figures. So when you do this, you are getting 11.90. You are getting 11.90. If you want, you can leave it in 4 decimals, so it can be 11.9099. 11.9099. So this is the application we are talking about under the geometric mean. Under the geometric mean. So we move on to another example under the application under the geometric mean. We move on to another example. So it says the population in Ghana in 1988 was 2. The population in Ghana in 1988 was 2 persons. 2 persons. By 1998, it was 22. What is the average annual rate of percentage increase during 10 years between 1988 and 1998? So now, as usual, we use our formula here. So it says value at the end of period, and at the end of period is 22. And value at the beginning of period is 2. And we have our n to be 10, then minus our 1. So now let's compute this into our formula. So you are getting 32.1662. 32.1662. Now we move on. So now we move on to median and mode of an what? Of an ungrouped data. So when you are given an ungrouped data and the middle value is an odd number, you would have to go with this formula in order to find your median. When the middle number is an odd number, you go with this. So the n here is the replacement of the odd number. Then you add 1 to the odd number to make it even. Then you multiply it by your half here. I repeat, when the number in the middle of an ungrouped data is odd, this is what you do. The n here stands for the odd number, then you add 1 to it to make it even, then you divide by your half. And when you are given an ungrouped data and the middle number is even, fine, you are good to go, you choose it. But when it appears that the ungrouped data, the middle numbers pops up twice. For example, you've been given an ungrouped data, then 2 and 4 becomes your middle numbers at the same time. What you do is that you add these two, then you divide by 2. You add these two, then you divide by 2 because it's 1 and 2, it appears twice. So you add these two, then you divide by 2. This is what you should know when it comes to median of an ungrouped data. So now let's solve an example. Let's solve an example. So it says, find the median from the following data. Find the median from the following data. 2, 30, 12, 25, 20, 8, 10, 4, 15. So now, you having these figures, what you do is that you arrange them from ascending to descending order. So you start with your 2, then followed by your 4, then followed by 8, 10, 12, 15, 20, 25, and 30. So now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these figures here are 9. So what you do is that your 2 cancels your 30 out, your 4 cancels your 25 out, your 8 cancels your 20 out, your 10 cancels your 15 out. Then now we get to spot our middle figure, which is the median, and it's 12. And now to God be the glory, this 12 is an even number. So you just state that your median is what? Is 12. If this number was to be an odd number, let's say if this number was to be 13, what you would have done was you would have stated this, then you proceed. So here would have been what? 13, then plus 1, then you are getting what? Half times your 14, then you calculate for it. But if it's an even number, you don't touch it, it remains the same. So now let's proceed. We proceed to mode. So the mode or modal class of a set of observations is the value or class with the highest frequency. When we talk of the highest frequency, the most common value of class, the most common value or class. When we talk of the most common value, it is the number that appears the most. The number that appears the most. So there is an example here. It says determine the mode from the following data. Determine the mode from the following data. So we have 25. And remember, what we are doing is for ungrouped data. So we have 25, 15, 23, 40, 27, 25, 23, 25, and 20 and 20. So now with this, there's no need for you to arrange from ascending to descending. You can spot, look at the most occurring figures, then you take it up. Then you take it up. So let's count. 50, 25 appears 1, 2, it appears 3 times. 15 appears once. 23 appears 1, 2, 23 appears twice. 40 appears once, 27 appears once, and 20 appears once, 15 appears once. So now the mode here is 25. The mode here is 25 because it appeared 3 times. It appeared 3 times and is the most occurring number. Is the most occurring number.